Hello and welcome to today's video. In this video, we are going to study about land capability classification. Okay, we are going to study about the land capability classification, which is defined by USDA. USDA means United States Department of Agriculture. Okay, so there are typically 8 classes of land starting from 1 to 8 in the Roman letter. Okay, and the four classes are called as the arable land. It means these are cultivable, and the last four, starting from 5 to 8, is non-arable. Means this land is not suitable for plowing or cultivation. Okay, and as you can see, the class 1 is 0 to 2% of slope, and class 2 2 to 5% of slope, class 3 5 to 10% of slope, and class 4 10 to 15% of slope. Okay, and then here are the other classes, and these have the other like problems. The class 5, which is flat, it can have the problem of waterlogging. Okay, or it will be saline in nature, like the run of Kutch. It has a lot of salinity in the soil. And then the class 6 comes, which has 15 to 25 degree of the slope, and here if you will plow the land, if one rain will hit, all the soil will get washed to the plain areas nearby the hills. So that's why you do not do the cultivation here. And what are the examples? The example is Western Ghat. And class 7, this is also non-arable, means non-cultivable, severe ravines like the Chambal Badlands. Okay, so what is ravine? You can see the image here. These things are called as ravines. And the Chambal Badlands, okay, this is the Chambal Badland also is an example of this. And these are like deforested areas. If like wind erosion is very much active here, so you cannot do agriculture here. And here, what is the standard management strategy required? The wildlife will be preserved here, or the nature will be preserved as it is. And then comes the class 8, the non-arable land, which is extreme, like the Thar desert or the Karakoram ranges, which are very much snowy, or the Thar desert areas, which can never ever be like managed for agriculture, and it should be left as it is. Okay, now talking about the examples of class 1, the Punjab plains, like the Punjab plains, the Ganga plains, the Mahanadi plains, the river deltas. Okay, these are very much fertile, and these have no restrictions to it. You can do proper agriculture. There is no management required. Agriculture can be done here, and this is called as the class 1 arable land. Then comes the class 2, 2 to 5%, the Deccan black soil. This is called as the example of the arable land of class 2, and this can be done there because there is 2 to 5% of slope. So basic contouring. So what is contouring? You can see the image like this. This is called as contouring. You can do the cultivation. And the 5 to 10% of the slope. So in Karnataka red soil, you can see the terracing. With the help of terracing, you can do terrace farming. And then the marginals of marginal class, that is the class 4 under the arable land. Okay, so you can, as here is a high slope. Okay, so you can do occasional cropping, or you can leave it as it is. Okay, so here we have just briefly seen the classification starting from 1 to 8. But I hope there must be some other questions to you. So now we will go in detail about why this classification was done, who has done this classification, and what was the need for the classification, and why the classification is only based on the capability of the land according to agriculture, and not other capability of land is considered here, like for urban planning or for other regions. Okay, so let's deep dive into the topic, and we will understand it in detail now. And if you want to skip to a particular point of the like video, you can just like jump to the timeline. Okay, and that is given in the description, or you can just speed up the video. The land capability classification system enforces a strict planetary reality. Successful human development requires aligning agricultural ambition with physical limitations of the landscape. Okay, so here is the reason that why there was a need for land capability classification. So first of all, what happened in the 1930s, the blind exploitation means the farmers flowing American prairies without understanding physical land limits. What happened during the war of like World War One, okay, around 1914, okay, 1914, the government wanted the farmers to grow as much as wheat they can grow, so that they can win the soldiers could win the wars. Okay, and there will be amount food sufficient amount of food supply for the soldiers. So that's why they said that to give the government decided to give as much as subsidy possible to the farmers for the cultivation, and also to give them proper pricing for the wheat. Okay, so what happened? The farmers started to grow their land and acquire a lot of cultivated land into their farming area. This was the first point. Another important thing is that before 1920s there was no use of tractors, only through the use of horse and mules. They used to cultivate they used to plow the land, they used to till the land. But after 1920, the invention of tractors helped them to plow like meter of land in seconds, okay, in minutes. So that's why they also started to plow a much more like large area of land. And the third point is that what happened, the urban dwellers like the bankers, okay, and the financially well off people, what they did, they brought the prairies and steppes of the lands in very cheap rates, and then they sold they used these lands to cultivate and to do agriculture by hiring some laborers. Okay, so they actually naturally they do not need to go to the land to earn. They just hired some laborers and one manager. They will cultivate the land, and at the end of the time when they will harvest, they will earn a lot of money. So this is why what happened, the agricultural land, the farming land has grown to a larger area in USA. Okay, and as a result the farmers tried to plow the prairies areas which was covered by grasses. Okay, which was covered by grasses. Then what happened, when they cut out all the grasses what was there, the soil started to become into fine particles. And as a result of what, when the wind blow from there, passes from there, the wind taken out all the dusts with itself, and it spread across the United States of America from one district to another district. Here you can see a video, here you can see an image of like how the disaster used to look. Okay, so this was called as the Dust Bowl disaster of 1930s. This is one of the most what you can say, one of the most devastating ecological disaster, man-made disaster. Okay, and going back to the topic, what happened? As a result, there was agricultural collapse. And yeah, another point I have forgotten, I am mentioning here is that during the 1930s, what happened? There was a unusual rain in this area, in this prairies area. So what everybody thought is that it will continue to rain, and they thought that, and they believed in a superstition that wherever there will be plowing, the rain will follow the places, and they started to plow each and every inch of land of the prairies. Miles of regions, miles of area get plowed. So that's after that what happened, when wind erosion become very much heavy, and a period of drought followed there. About 10 years of drought was there. Okay, now coming back to the um, land capability classification formation. Okay, US government created the Soil Conservation Services in 1930 to map the land's survivability so that they will publish colorful maps, as I have shown in the video that this class 1 has dark green color, class 2 has light orange color, like that. Okay, they will show the prepare a map of United States of America, that which land is arable, which land can be plowed, and which land is non-arable. Okay, now the definitive response was published in 1961 by A. Klinkbell and P. H. Montgomery, USDA Handbook number 210. Okay, creating a system to save the soil ecosystem. Now, the hierarchical triage system designed for three core outcomes. First, prevent disaster. Okay. Scientifically separate safe plow zones from fragile steep hills where soil will blow or wash away. Second, match the crops to land, maximize agricultural efficiency, ensure intensive farming only occurs in the land physically capable of long-term soil sustainability. Then third was the guide policy and subsidies, direct government funding, determine which land must be retired into national forest or conservation reserves. Okay, so this was the three step 1, 2, and 3 the government initiated to manage the soil, to manage the environment, and to conserve the soil. And as you can see, this is initially done by USDA, but India also adapted it, and this is adapted worldwide. See, when there is a problem in United States, they find out such a solution that is adapted worldwide. Okay, so this is a thing we should learn. If there is a problem in India, we should also do research and find out what could be the solution which will set the example for the entire world, and people from around the world will adopt the India's invention. Okay, so the adapters managed by All India Soil and Land Use Survey and the National Bureau of Soil Survey Land Use Planning. Okay, they adapted this and adapted the exact USDA 3-tier framework, but recalibrated all soil matrices to withstand the extreme realities of Indian monsoon climate and native soil profiles. Okay, they have considered the Indian climatic condition and also the native soil profiles. Now, the 3-tier architect targets both landscape and the farm. So first of all, there is a tier hierarchy system. First is the classes, the capability classes, as you can see here. Under these capability classes like 1, 2, 3, 4 till 8, there is subclasses, that is E, W, S, and C. The nature of the problem identifies the specific physical hazard restricting the land use. Okay, so we will discuss this for it further. What is E refers to, W, S, and C also refers to. Then comes the capability units, that what kind of management level it needed, the soil is needed. Okay, so groups specific soil requires identical conservation treatments and terrace designs. Okay, this is micro level farm planning. Now coming to the 4 diagnostic subclasses. First of all, as we have classes studied here, that under classes there are subclasses. Now we are talking about that subclasses. So there are 4 subclasses: E, W, S, and C. So E stands for erosional hazards, the susceptibility to sheet, rill, or gully erosion. Okay, when you are talking about erosion, it will be called as E. So suppose that is class 6E. What you will understand? This is non-arable land and it has the problem of erosion. Okay, and when there is W, it means poor drainage, waterlogging, or flood hazard. So when there is problem of water related problem, okay, wetness or drainage problem, that will be referred as W. So suppose the class is VW. What you will understand? This is class 5 and W means it has drainage problem or wetness problem. And when the letter or the subclass is S, it means the soil problem, the root zone problem, the shallow depth of soil, stoniness of soil, or severe salinity or alkalinity will be the problem. Okay, and This C refers to the climate, extreme temperature or lack of rainfall. Context, restricted areas like arid and desert of cold Ladakh. Okay. And for E, the context is the most common limitation in India due to intense monsoon downpours on unprotected soils. E means erosion, and erosion is very much prone in India because of the monsoon. And W, common in coastal areas and low-lying river plains. And S, this is identifies difficult Ushar lands. So I hope you have seen the video of types of land by ICAR. If you have not seen it, then you can go to the playlist and see the types of soils of India defined by ICAR. So Usar means the barren lands. Okay. So now coming to the next slide. The great divide, arable versus non-arable landforms. Arable landforms comes under 1 to 5, sorry 1 to 4, and non-arable lands come from 5 to 8. And the status, these are suitable for cultivation, this is not suitable for cultivation. Okay, so the rule is as you move from 1 to 4, landforms steepen and soil degrade, requiring an exponential increase in conservation efforts, contouring, terracing, to prevent degradation. Okay, so 1, 2, 3 and 4. So tell me which land will be having the most suitable land for agriculture and which will be having least suitable land for agriculture in the comment, and tell me which land will have moderate slope among these 4 landforms. Okay, so as here what it have written, the landform steepen and soil degrades. Okay, landform steepen and soil degrades. So tell me among 1, 2, 3, 4, which land will be the having this moderate slope. So, and here the rule for the non-arable land defined by permanent physical constants like extreme steepness, flooding or rockiness, strictly restricted to pasture, forestry and native wildlife conservation. So these lands, okay, 5 to 8 is strictly restricted to pasture, forestry or native wildlife conservation. Okay, now talking about the topographic blueprint, mapping classes to natural landforms. Slope and soil dictates capability. The higher the classification number, the more the restricted human intervention must be. Okay, so as you can see, the loss delta green, this comes under class 1. Okay, and beside the class 1, you can find class 5. So why? Because it has the problem of the wetness or waterlogging problems. Okay. And then you have the class 2, the loss delta green. Okay. These alluvial fans are very like gentle in slope. Okay. And this can also be done for the cultivation, gentle upward slope. Then warm arid org class 3 and 4. Okay, these areas are warm and but arid, and you can do cultivation here, but you need the terrace farming or contour farming here, and this comes under the deep forest green. Okay, and this comes under class 6. Class 6 means this is non-arable land, and this is the class 7. Okay, deeply eroded ravine and badland. With the example of Chambal we have seen, and the harsh slate gray color, this is the class 8, and this is for jogged barren rocky glacial peaks. Okay, so I hope this image would have given you a clear classification of the land classification, how the lands are being classified, and this looking into this image you will definitely get a clear view, clear image of how the classification is done. Now coming to the classes in detail. Okay, so the agricultural backbone is class 1 and class 2. Okay, the slope is 0 to 2%. Here the slope is 2 to 5%. The matrix 0 to 2% slope, deep well drained soils, no subclasses. Okay, so what is the examples here? The highly productive alluvial plains of Punjab, Haryana and the Mahanadi Delta regions. And 2 to 5%, you can see here it is the contour farming. Okay, the 2 to 5% slope, slight limitations, require basic conservation, the contour bonding. This is called as the contour bonding. Common subclasses 2E. 2E can be seen as the common subclasses, as E stands for erosion and 2W slightly waterlogging. Okay, these soil have these common problems. Indian context: gently sloping black soil of the Deccan Plateau, elevated interfluence like dobes. Okay, now coming to the class 3 and 4, the moderate limitation and marginal arable lands. Here the slope is 5 to 10%, here the slope is 10 to 15%. Okay, requires special practices like terracing to maintain viability. Common subclasses: class 3E, moderate slope. Okay, E means erosion, S means shallow or saline soil, and common subclasses are VE, that erosion, and VC, severe semi-arid region. Semi-arid, when C is there, it means climate. Okay, climatic factor. So I hope you are now revising also in this video that EWSC. What E represents for erosion, W represents for water problem, S represents for soil problem like stoniness or salinity or like the shallow depth of soil, and C represents for climate. Okay, in Indian context, what kind of classes will come under class 3? The undulating red laterite soil of Karnataka, Odisha, fringes of Chotnagpur Plateau. And in Indian context, the degraded lower slopes of Sivalik range, marginal lands bordering the Thar desert. Okay, hope you have like seen the in the map where is Thar desert, where is Sivalik hill, and where is Chotnagpur Plateau is situated, where is Karnataka, where is Odisha, where is Western Ghats, where is Eastern Ghats. If you have not seen this, then you can comment in the comment section, and I will make a separate video to show you the important mountain, rivers, deltas, plateaus, okay, and other important features of India in a map class. Now coming to class 5, the level of anomaly. Okay, the paradox is here that the flatness does not equal farming. Okay, as we have seen in the class 1 that it is 0 to 2% slope, means it is more or less a flat land, but here class B is also a flat land, but this is not good for agriculture. Class B land have slopes, gradients identical to class 1, nearly level. Nearly level means it's flat, but suffer from permanent non-erosional limitations. The VW, permanent swamps or waterlogging. In Indian context, the saline tidal marshes of Run of Kutch and the permanently waterlogged Tarai belt in Himalayan foothills. So hope you know where is Run of Kutch. Hope you know where is Tarai belt. Run of Kutch is near the part of Gujarat of India. Okay. And coming about the problem for class B, that is VW, that is permanent swamp or waterlogging problem, and B is for extreme stoniness. Indian context, the rocky riverine islands of Brahmaputra. Okay, so coming to the next class 7, sorry, class 6, the agroforestry and plantation zone. The 15 to 25% slope standard row cropping caused rapid irreversible topsoil loss. So the Eastern Ghats, the Western Ghats, these are the places where you will see this kind of problem. And the like VE, steep hillside, VS, extremely shallow soil. Indian context management, these are found in the like Western Ghats, in the Eastern Ghats. Okay, and coming to the class 7, the catastrophic degradation and severe slopes. Okay, now we have come to the second last of the soil class. In the this is restricted uses profile matrix, very steep mountain slope or deep ravines. Hope you know what is ravine. Here it is a image how it looks. Any removal of vegetation guarantees catastrophic land degradation. So if you will cut the forest that is present here on this kind of land, or remove the grasses, whatever is naturally grown here, the soil will definitely get degraded. Primary subclasses is VII. E refers for erosion. Okay. Restricted uses, severely restricted to native woodland or wildlife preservation only. No agricultural extraction is safe. You cannot do agriculture here. In Indian context, the intricate, deep badlands of Chambal ravines created by unchecked severe gully erosion Okay. And highly deforested Himalayan faces prone to landslides. Okay. Himalayan faces prone to landslide. Okay. Now coming to the class 8. Class 8 refers to the physical extremes. The reality, extreme environments with absolute zero commercial plant production potential, lacks actual soil capable of supporting crops. Okay, there is no actual soil that can be used for cultivation. So primary hazards are C, first of all the climatic, extreme climatic conditions, and S, the bare rock or sand areas like the sand and the ice. So shifting Barkhan dunes of deep Thar desert in western Rajasthan. So what is a Barkhan? If you are a scholar of geography or student of geography, you should know what is a Barkhan, whether it is a depositional landform or erosional landform. Okay, and then so here I am showing you a image of Barkhan and barren granite domes in Deccan, deep Deccan interior, and the permanent snow fields of glaciers of Karakoram range. Okay, so this was all about the 8 subclasses or 8 classes of land capability classification. So hope you have enjoyed the video. You have studied well in the video. This was a deep discussion, and I am damn sure if you have seen this video entirely, you will never find anywhere else in deep in this detail for this topic. Okay, so to get more videos like that, you can comment it in the comment section, and also if you want to advise anything like this can be improved or that can be included, you can also like comment it in the comment section for any kind of improvement in the video. And also like if you want any new topic to be discussed, that can be also commented in the comment section. So thanks a lot and have a great day.